small baseness, the questions will be like this only. Very, very small questions will come. Okay, read the question now. Quotient of this one. So the DL should be equal to alpha d theta. There's a general definition. So this alpha now, what is alpha? Alpha is a function of temperature. Alpha, we assumed it to be constant, but it can vary with the temperature. LA T dt. So what is asking now? So this will become dl by L equal to A T dt. Then the temperature at which the length will be 2L. Initial length is L, 2L at 0. At what temperature? It is that one. So this will become log L A T square by 2. So log 2 is equal to 2 log 2 by E. I think you can simplify further. The length of the rod, even what will happen, the alpha can vary with the temperature. I do have some problems of like this, I'll bring it. But anything, there's a generalized formula, just stick on to this idea. Let me discuss one more. Now, if there's a rod, the temperature at one end is T1 degrees Celsius, at other end is T2 degree, and it varies linearly. Let alpha be the quotient of linear expansion. Let L be the length of the rod. Where I'll give a graph. There's a graph corresponding for the variation. So this will be T2. This is T1. Is asking to calculate find the elongation of the rod. The temperature at one end is T1 degrees Celsius, at other end is T2 degrees Celsius. So we do define this is x equal to 0, x equal to L. Is asking find the elongation of the rod. So again, the basic method is what like, whatever the type of problem. Let me take small element. Let me define a small element. The length of this element be dx. Shall we first find out the elongation in this small element? Before that, what about the temperature? Temperature varies. So what is the temperature at this particular point? We'll find out the variation of temperature here. How to get temperature at any distance x? Anybody, any formula? I think, shall we use this one? T2 minus T1 by L should be equal to T minus T1 by X. So this is equal to T1 plus T2 minus T1 by L into X. From where I brought it? From where I brought it is, so here T2 minus T1 by L should be equal to T minus T1 by X. Can I use this temperature per unit length formula? Or I'm asking write expression for temperature at a distance X. Mathematics equation of straight line. Okay, now we have this one. So let me write here. So the elongation in that small element dx alpha temperature is T. Thermal elongation due to in a small element of length dx, let it be delta L. So what is dx? Length of small element. Let delta L be the elongation due to change in temperature, because as you move from here, T and this will become dt. Are you getting this one? So therefore this will become now dx alpha. What is T? T1 plus T2 minus T1 by XL alpha. Okay, let's do one thing. Yeah. Alpha T1 dx T2 minus T1 alpha L x dx. So the elongation in that rod will be 0 to capital L, the limits. Alpha T1L T2 minus I think you can further simplify one more step. Alpha L T1 plus T2. Okay, this will be the elongation in the rod where the temperature at one end, it varies linearly from one end to another end. If alpha varies, you know what previous problem we did. Here, if the temperature varies from one end to another end, so how to find out elongation, there's a method. Okay, read this one. Let me have a water. I gave diagrams also.